This is part 2 of day 19 of Advent of Code. In the first part, we ingested a bunch of rules for a sort of a grammar of sorts, and we took those rules and we applied them to a bunch of messages that we've received to check which of those messages were valid and which were invalid. Now here in part 2, we have 2 updates to the rules that we were given because the original ones we were given weren't quite right. So we have 8, which was originally 40 pointing to 42, and 11, which was pointing to 42 and 31. Both of those now need to be updated to these. Now what's interesting here is that these rules contain loops. They contain self-referential loops. So 8 points to either 42 or it points to 42 and 8, so it's pointing to itself. And similarly, 11 points to either this or this right here, which contains 11, which points to itself. So when it comes to rule 8, if let's say 42 was reduced to just the character A, so 8 would either match on an A or it would match on an A followed by either another A or an A followed by another A, so on and so forth. So it's kind of what we think of in regex with the plus operator, where it's like match on one or more of 42s. So I can imagine updating some of our code from part 1 to sort of special case rule 8, having it be sort of embed that plus character in order to get the one or more matching going. However, when I look at rule 11, what we have is some nesting. So it's 11 either matches, let's say, A or B, or it matches A and B plus another 11. So it's like we could have a set of A's on the right and a set of B's, or a set of A's on the left and a set of B's on the right. But those, like, it'd be sort of like having to have balancing parentheses, right? We'd need the same number on the left as on the right. And I'm not sure that there's a way to do that in regex. Sort of feels like that's getting into the territory of more of a formal grammar, which they're kind of warning us against down here with this link. So yeah, that takes me to this like hint that I think we should take pretty seriously, which is that we really shouldn't try and handle rules, any sort of rules. We should really only handle these 2 rules that we're given. Otherwise, we're at the point of writing a formal grammar, a parser for a formal grammar, and we don't have time for that. So the way that I'm thinking about approaching this, like I said, this I could see encoding in regex. This I'm not sure. The second rule I'm not sure. So maybe there's a shortcut for both of them that we can take. Thinking about, a string of characters like this, I think it's about 40 characters. That's about as long as it gets. So I'm wondering if we could programmatically replace this with 42 or 42, 42, or 42, 42, 42, so on and so forth, basically saying that 8 can either match 1 or 2 or 3 or up to like maybe 40 consecutive 42s. And then similarly with 11, if we could programmatically generate a series of splits like this, where it's 42 31 or 42 42, 31 31, so on and so forth. If we did that, programmatically generated that, injected that in our sort of pre-parsed rules, and then just let our solution from part 1 run, I think we might have some regex that would work. So I'm going to at least start with that approach, and we'll see whether it works or not. So let's jump back to here. That was our answer for part 1. I'm going to save this as part 2 so that we have our own file to work with. And it's down here when we're parsing the rules that I want to sort of intervene. So we've got 8 and 11. And I want to say that if the ID equals 8, then we do something. Else if the ID equals 11, we do something, oops, else we do this. So this is sort of our default for handling rules. If it's not rule or 8 if it's not 8 or 11 that we're dealing with. So with 8, yeah, I wonder, I'd like to just open up a pry real quick and think how I could generate basically what I was describing before of 42 or 42, 42 or 42, 42, 42, so on and so forth. Like, how do I generate something like that? I mean, it seems like a recursive thing. So maybe, or not even necessarily recursive, but we're just going to have to do an iterative thing. So we'll say like from 1 up to 5, just as an example. Really 5 is going to be like 40. Yeah, so I think 2a, yeah, that's a list like that. So for each of those, we're going to have some value. And whoops, I'm going to break out of that because what I want to start with is a rule definition, which is going to equal just an empty string. Then we jump into here and we say rule definition gets updated to, or maybe we can do some string concatenations. Say rule definition or, and then what do we want to stick on the end of rule definition? Yeah, we want to tack on sort of any number of the, you know, a 42 for every the number of 42s that matches the number of values we're at. So if we're at a, you know, value 3, then I'd like to be 3 42s. So how am I going to do that? I guess let me break out of here again. Okay, so I use something like that times and then we could join on an empty string like that. Okay. So let's say rule definition is 42. Then we go 2 up to 45. And we say rule definition gets rule definition or, and this is where we say 42 times val dot join, like that, and we'll just need a opening paren there. Oh, okay. And so what does rule definition look like then? Yeah, 42. So I like the looks of that. Let's copy this, jump out of here, and paste that there. So we'll start our rule definition like that. This is specific to 8. We will then say for 2 up to, I don't know, let's say 45. We will grab these rules and I've got an extra n there. And we will, yeah, just keep updating the rule definition by appending some number of additional rules onto the end there. So yeah, I think that'll work. And so then can we do something similar with 11? I think so. Say front gets 42. Say back gets 31. Say rule definition gets front followed by back. And then for each subsequent one, oh, no, not quite. Yeah, this isn't quite right, because what we need to be able to do is inject in the middle. So yeah, we'll build up our front and our back as we go, and then at the end, the rule definition, oops, definition, weird. So I'm calling these rule descriptions down here and then rule definition. That's fine though, we'll just stick with that. That's where this will become this. Okay. So then for 2 up to 45, we want to say front Now I'm talking myself in circles here. So I do like this for rule definition. And then for each subsequent one, we say front gets yeah, like plus equals another front. So we kind of tack on another 42 if we already had a 42, and then the rule definition then becomes an or followed by the front and then followed by the back. So then we need to do the same thing here with back. And we don't end up using val in this. So this 44 times do. That'll work. I guess I'm kind of curious if I copy this and open up a pry. Uh-oh. Did I freeze it up, or is it? I'm not sure if pry is thinking or if I just put it in a weird spot by copying and pasting in those things. I think this looks like, yeah, 42, 31, 44 times do. Not sure what its rule definition. Okay, it's pretty jammed up here. That's too bad. Yeah, what does that leave us with for rule definition? Oh, brother, I'm really locking it up here. I'm not sure why that is. It's not that big of a string. I mean, it's big in terms of it's probably going to take up this whole screen that we're looking at, but I mean, it's just going to be, I don't know, a few hundred characters. Or am I underestimating how big it'll be? Each iteration, it goes from 2. Yeah, it started out as 2. Then the next iteration, it becomes the original 2 plus 4. And then it's the original 6 plus 6 more. And that's that original 12 plus 12 more. Yeah, I don't think it's that much. Wonder if we got the logic wrong. I'm gonna see if I can break out of here and rework the approach. Come on, Pry. Just twiddling my thumbs here. Pretty surprised we've locked it up this bad. I'll open up a tmux split and okay. So let's jump into 19 here. Open up part 2. Uh-oh. Well, must have had unsaved changes, so I'm gonna quit. Okay, now we've freed up this. Well, even exiting is okay. So something we did here, it really just didn't like. I mean, I feel like I stand by it though. We just keep on appending more pieces here. Maybe 44 times is just too many. Okay, what if I say 4 times and try and run this code? Okay, and then what is rule definition now? Okay. Yeah, so I guess if I'm kind of curious, if I split that on, yeah, I think maybe this was just overkill. If I split that on this, and I grab the last one, and then I say split on space.size, that's 32 characters. So if I even took this up to 5, I feel like that's enough to cover us based on the length of these strings. So I'm going to leave that, do this 5 times. The rule that comes out of here, that's what we're going to put in higher order rules for the ID of 11. We're going to say it gets rule definition. Okay. Similarly for rule 8, we're going to set the rule definition. Okay. So with those 2 things in place, kind of curious if we can just rerun the whole thing as is and get an answer. So I think we're still set for input. Let's see what happens with part 2. Okay, so line 64, no implicit conversion, symbol to integer. 64. Oh, whoops. We have a format that we need to use. It's this right here, so 11. This can be rule definition, and then we know what deps is. In this case, it is 42, 31. Those are the only two that this rule depends on. And then similarly up here, we have 8. And the only rule it cares about is 42. Awesome. Let's give that another run. Oh my, what did we spit out here? That's a big regex. Holy smokes. Where's the top of it? Okay. Oops. So what happened? Output error. Oh, looking at the wrong. Too many capture groups are specified. Wow, we've I guess we've pushed Ruby to its limit here. I have never seen this error before. I feel a little bit proud of that, but I'm also not sure what we can do to modify the solution. I mean, I never really cared about the capture groups. I just wanted a way of, you know, oring things, because it's like this or this, and so you wrap it in parentheses to assert that, but in the process it creates all these capture groups. Well, I wonder if we can bypass. I don't think it's going to make any difference, but I wonder if we could, if we run it like that, then we either get 0 or nil. So, or we get some integer or nil. So what is not a 0? That's true. Great. Okay. I don't think this is going to make any difference, but we'll see. And not pry part 2. Yeah, it's the same thing. Regex error. Too many capture groups. I'm kind of curious to check now. Yeah, I don't know. Well, not really seeing anything in the Google results on that. It'd be nice to get a sense of where we are. I'm wondering if I can leave the 11 in place, because I think we have to specify it like this. And if I can reduce the number of captures by special casing 8 once it gets interpolated in as regex. So what if I do that? Just have the if ID there. And once we get down to reducing the higher order rules, I would love to know if ID is, oh, you know, we're never even going to end up with 8 here because of this filter, because we're always going to end up with a dep here of 8, and the reduced rule keys is not going to include 8, so we're always going to bounce 8 out of this rules to reduce. So I kind of wonder if, yeah, if this is empty, or or if ID equals 8 and reduced rules (42), I believe it was. So 42 is already a reduced rule, and it's 8 that we're looking at, then we'll include it. At which point, if the ID was equal to 8, then we want to do something else. We do our regular stuff. So yeah, we want to do rule part split, rule ready to wrap, reduced rule. So that'll be our end. This is our else block. Otherwise we say reduced rule is or nil or something, just because we have to define that outside of this block. So anyway, the reduced rule could equal, I guess, yeah, what do we look up reduced rule piece? So I would want to say that the reduced rule is an open paren, then the reduced rules 42, so whatever that has been defined as. Right, reduced 42. Yeah, whatever that's defined as, then we close that and we say it's any number of those. Because that was the definition we got, is it's one or more of whatever 42 is. Oh no, we need to close that. So then that becomes our reduced rule, which then gets added in here for 8. 8 gets removed from our order rules. And then I think we've still got a valid regex at that point. So will that run? It does. Okay. So I guess I brought us down to our threshold of capture groups that can be contained in one of these. Is that the answer though? Will that get us our gold star? Not quite. The answer's too low. Okay. Well, I guess the other thing I wonder about is, do we need to bump this number up to like 6 maybe? Let's try it. No, that's too many capture groups again. Okay. Well, I'm feeling a little bit stuck. So we've got an idea of 11. We go through and, yeah, we say some number of 42s and then that same number of 31s. That's what this is kind of describing. And I think we've done that. We've said, yeah, we said give us some number of 42s, some number of 31s, and it can be any of those. Yeah, I think that works as a definition here. Okay. So what about the 8s? I guess I'm kind of curious to print out whatever the reduced rules 42 is for our problem. I'm sure it's just going to be some big massive parentheses, A's and B's. It might not even look particularly intelligible. Yeah, that's what I was afraid of. So we're taking that whole thing, I guess, and just, I guess we don't need to wrap it in another set of parentheses. We just need to put a plus on the end. Does that make any difference? No, we still get 241, which wasn't the right answer. Wrap reduced rule. Yeah, I'm not sure how else we could. I mean, I guess my concern at this point is that because of the limitation here, we've maybe not created a regular expression for 11 that matches all of the possibilities that it enables. And so because of that, we're not getting because of that, we're not getting we're not matching as many things as we could be in our string, in our series of received messages. And so we're ending up with 241 instead of, I guess, a higher number. Yeah, your answer's too low. Kind of curious. Rules. Receive messages. I wonder how many of these we have. Yeah, count. So there's 329 of those. We're saying 421 are valid. Yeah, there's a lot of ground to cover in between those two numbers. Okay. So what do we end up here with for our rule definition? Oh, there's our mistake. We're doubling these each time. Oh, shoot. Okay. I'm glad I caught that. So yeah, I guess I want to say like running front, running back. And so the rule definition gets I guess that doesn't matter, that can stay the same. But then each time we go to update, we're going to update the running front and the running back with this front and back. And realize we've got like a football term in here now. And then the piece that we add on here each time is the running front and running back. And so if we do that and give this another run, well, this looks more reasonable now, and we get an answer that might be our answer. So return to day 19, pop down here, is 253. All right, we've now got our second gold star. It's just a little oversight in some of that logic. But yeah, we got there. So thank you for watching.